Hi all, this is ICP5 for Python deep learning class. Today's exercise is to create a k-means clustering on the given data set and also find out the silhouette score of it. So the data set is, first look at the data set here. So from these are the column names. So first I'll be eliminating these two columns and calculate on the numerical data, and my label here is a graduation rate. So to make it even more categorized, I'll be adding another additional column, which I'll be discussing now. So let's quickly run it in the meanwhile. So I created a method here which reads the data and appends a new column based on the values. If the graduation rate is less than 25, I'm just returning it as a category 0. So until 0 to 3. So once that column is set, first we read the data here, remove the non-numerical columns by using drop, add a new column here and extract those as x and y. Right now here I'm using a programmatic method to calculate the number of clusters. From my example, the value which I got is 5. So we'll also evaluate whether it is the right value for the number of clusters or not. Now we plot the initial data set here, that is using facet grid. The input, the x and y axis are enroll and SF ratio for the first, and enroll and graduation rate for the second. So let's compare these two. And the hue is the third dimension here in the plot, which is the graduate rate and the rating. So with this plot, with the enrollment here and the graduation rates between 20 to 100, I have categorized them into 4 levels. And the same way with the enrollment and the student to faculty ratio, the data is plotted using the figure 1. So once we plot the figures, then we proceed with calculating k-means clustering. We use a transform standard scaler to transform the data and fit that to the scaled version of the data frame and find the k-means clustering on the given number of clusters. Here it is n is 5, and then we predict it. I've created a legend that is for a map to plot the clusters using 5 colors. Because my initial input columns are from column 2 to 13, so I'll be using dimensionality reduction here as well using PCA, which is under a scalar and dot decomposition. So once we import that, we do a fit transform to it, take the new variables, and then calculate the centroids out of it and plot the data from which we get this. So I represented the centroids using the cross mark here. So this is the plot and the code for it. So now we'll evaluate whether the plot is right, whether the calculated centroids are right using the elbow method. So from this plot we find that a cluster between 3 to 4, or ideally 3, is the valid number of clusters for the given data. So my assumption of clusters being 5 is proven wrong with this. So we learn from the data that the ideal number of clusters are 3. And that's it. Thank you.